On a hot, sweaty day, all it takes to rid yourself of the heat is to switch on the fan. Cool breeze fills the room. But can you explain the physics behind this fan? The physics behind the electric fan is the conversion of electrical energy into mechanical energy by using the principle of the magnetic effect of electricity. This converted mechanical energy is used to rotate the blades of the fan. Inside the fan, all this is achieved by the electric motor. The electric motor finds many practical applications in our daily life. It is used in appliances such as refrigerators, washing machines, and food processors. So, can you explain how the electric motor works? At the heart of the electric motor is a magnetic field. If you place a current-carrying coil in this magnetic field, the field will exert a force on the coil. This force causes the coil to spin, thus converting electric energy into mechanical energy. This is the principle of the electric motor. But how can this principle lead to fan blades rotating? To understand how the fan blades rotate, we need to understand the parts of the electric motor and how these parts function to make the blades rotate. Electric motors are constructed to convert electrical energy into mechanical energy and mechanical energy into rotational motion. The motor consists of a rectangular coil ABCD of insulated copper wire that is placed between the poles of a magnet. The arms AB and CD are perpendicular to the direction of the magnetic field. The two ends of the coil are connected to the two half rings P and Q. The rings are free to rotate when the coil rotates. The carbon strips X and Y are used as brushes and are fixed to the base of the motor. They are tightly pressed against the two halves. The reversal of the flow of current is decided depending on which brush is being touched by P. A battery is connected to the brushes to supply them current. Now, let us see the working of the electric motor. When a current passes through the coil ABCD, the two ends AB and CD are perpendicular to the direction of the magnetic field. The forces of these two arms act in the opposite directions. The current flows from A to B, so the force acting on AB is downwards, and then from C to D, so the force acting on CD is upwards. Now the coil and the axle rotate anti-clockwise. When the coil reaches the vertical position, the carbon strips X and Y are on the gap between the two half rings. The coil completes a half rotation. The current now flows from D to C, and the force acting on CD is downwards. On the other side of the coil, the flow is from B to A, and the force acting on AB is upwards. Thus, when the flow of current is reversed, the direction of force is also reversed. This process is repeated, and the coil keeps on rotating continuously. This rotation results in the fan's blades rotating.